DraftScience video. I'm trying to make it all day, but just really haven't been up to it. Still a little wiped out by the Lyme disease and such. So anyway, yeah, the last video on the two-slit thing. Yeah, probably gonna undo a lot of that. You know, I've long stated that this whole two-slit, single-slit thing is all kind of bogus because the real issue is this Newton's ring thing, and they've never properly accounted for these patterns that are called diffraction and how they're any different. You know, when you really look at them, it's the same difference. You know, it's just a bar pattern hidden in a circle, same difference. And you have this idea of the dark spots, which are the tricky parts to account for. And you can say diffraction, but diffraction would require you know, you still would have to have some sort of uneven diffraction, some sort of angular diffraction to account for the fact that you have a spreading of some kind of, you know, a circular wave spread would just spread evenly, you know, circularly. You'd have to have like an edge to it or something, you know, some kind of reason for there to be a separation where you'd have the dark band, you know, something to diverge the light for some reason, you know, to create the dark stuff. If it's not going to be called interference, and they don't have a theory for any of this stuff. So yeah, so this is really the thing that has to be explained, is all of these interesting you know, manifestations of circular diffraction. And you have all kinds of diffraction though, not just circular. And some of it is just really interesting, and some quite complementary to what I'm arguing. You can sort of see it in this image. I don't know if you can see it very well, but there's lots of breaks here that fan out, and you know, that would be suitable to some sort of idea of individual electrons having something to do with this. And you do see that in different photographs of real patterns. There's so many simulations that you know, it gets hard to be able to separate reality from that which has been synthetically created. So anyway, it's lovely there. And the math for these patterns seems to me to have some sort of variance in terms of intensities. For apertures, it seems that the central maxima is much brighter than even in the single slit experiment. You know, in kind of almost preposterous proportions. This is a good image. I have that up from another page I found, so I'll go to that page. Lots of good images on this page. You know, regular surface. You know, sort of indicating that surface has an awful lot to do with this, but that it's more than just a surface, because the triangle, this triangle, so this is a triangular aperture, and it's clearly doing something very different than, say, a rectangle. You know, a rectangle's clean, not too much extra stuff. I mean, this is all the extra you get, is this little tiny bit. And look what a triangle does. On the points you get a huge amount, and you don't have as many, you know, the bars aren't as sharp. You know, they're kind of weak on the secondary pattern, and you know, it has this indentation stuff, and you know, very clearly it's not just a surface thing. You know, that if it was just surfaces and surfaces all did the same thing, then any shape you made would have exactly the same consequence. And that's not what happens. You know, there's very different shapes depending on the aperture. So let me see if I can find the aperture pictures here. Here they are. So these are really instructive. You know, a square creates the pattern going both ways, and then I guess a hexagon, lots of crap happening, and then you go to 6 sides and get less crap happening. So it's interesting. 5 sides, more crap. 6 sides less crap. Then an even roundisher aperture creates this weirdo stuff, and then the circle does this blend. The part that's wrong about this is that obviously this blend isn't what happens when you have a circular aperture. You do get rings, so they took out all the ring part. So I'm just saying this is where the bars would go. You know, they just don't put the bars in, so to speak. So yeah, I mean, all the two slit is completely uninteresting in this context. I mean, you know, it's just the idea of two patterns being superimposed on each other, and they don't have any math that does that except a crude sledgehammer kind of math, where you just do the one formula and then you pretend you can just cut off all the stuff the one creates. You know, you just superimpose one on top of the other mathematics and just cut off the extra bits. And so it's just contrived math. It isn't explaining a process at all, and it isn't explaining how the two functions can take place at the same time. Yeah, so there's that image again. You might be able to see a little better how it has a little bit of what you might consider a sort of interference pattern, but it's really just a stagger in the on and off. So anyway, somewhat interesting, and something I have to work on in terms of, you know, figuring it out, you know, mechanically, because there really isn't a mechanical explanation, and there's no, Huygens doesn't cover this at all. I mean, it doesn't explain these different apertures and the results you get with them. There's something going on in the atmosphere of the slit, the shape of the hole itself, the atmosphere inside that hole is different, and you can't explain it with one equation because it's dynamic. What the different sides are doing is important, and the double slit and single slit math ignore all of that. So, I mean, the double slit math ignores even how wide the openings are, essentially. It's that bad. So I'll deal with it. Hero left a couple of really lousy comments, of course. Typical of him. Oh, Superior Mind answered one of them. So that's good. He probably pointed out the obvious, and then maybe he'll do it more eloquently than I would have. Okay. Let's see. So he keeps saying I'm misstating something, which is absolute crap. Alright, so I point out here, he leaves a couple of these links to these synthetic experiments. And I point out how this synthetic experiment is not, you know, this doesn't do people much good, these synthetic punch in your numbers and get the answer thing. And it doesn't explain at all how the math is done in terms of, you know, doing both this thing called diffraction and this thing called, whatever the other thing is, diffraction and interference. So diffraction and interference. So they're claiming that this stuff inside is interference and this stuff outside is somehow diffraction. You know, somehow the shape of this thing's being dictated by some kind of diffraction thing, and, you know, which is the single slit. So obviously we know that the single slit made wide is going to have all these bars in it. And by what theory does the Huygens wave, the single photon, diffract into 7 or 8 photons, or 10 or 12 or 20? How does that happen? That the Huygens wave, you know, does this. So, I mean, I think it's clear that you end up with a Newton's ring, even if you have single photons. Although, as far as I know, no one's bothered to do the experiment, which is part of the whole problem here, is that no one bothers really testing any of this stuff. Sorry, I had to murder it. It was, you know, it was interfering with my video. Anyway, not stupid anymore, Gary. That's right, it's out of harm's way. Nice quick end. Anyway, this is all you can hope for. So anyway, this is not a this isn't going to explain anything. I mean, there's no math here actually. There's just no explanation whatsoever. But this is his typical bullshit. Like somehow this explains something. It doesn't explain shit. All right. So the other thing is, Glenn Oaks, who I really like. We did point out that. So if you're blocked from my website, it might be that you're using an ISP where a lot of trolls work out of. So you'll have to let me know here or someplace, if you can't access something, getting the errors and whatnot. It's probably because I have your IP blocked because I blanket block when convenient. A whole class of IP addresses. So anyway, all right, so. The idea you keep misstating is not exactly the correct spelling, but whatever. The wave doesn't go ahead of the photon. The argument is the photon is a wave packet, a pulse wave. That doesn't mean anything. Clearly you have to invest in some sort of theory that the wave does something. For it to do something, it has to go ahead of the wave and create the interference pattern for the photon to go somewhere. So you can't have it both ways. So either it's creating a navigational wave in front of it, or it's not. If Huygens doesn't spread, it doesn't do anything. It doesn't create single photon interference. Alright, I can draw a picture of this and show an animation of the mechanics of this. Let's see. Brace yourself. How can you do some research, superior mind? How about you do some? Here's a sample I found, approximately 10 seconds. So this will probably be the real, just a standard crap image. So we'll go look at this. It's really super to have neato music with crappy animations. Okay. So yeah, this is the same old bullshit. Let's use little dots of light bouncing off and all this other bullshit. So how does this explain anything? So that was particles. And there's no reason to think particles wouldn't go through atmospherics. Again, you could argue that if you made the particles out of styrofoam and there was charge on the plates, that they would be deflected. So it's just a cheat of the argument. And so this is the same dot. So how does this explain how these waves are interfering if a single photon goes through? Right? So let's jump ahead to see if they did the single. Oh wait, this even has a silly eyeball thing in it. There's never been done, douchebag. So again, yeah, just post links to crap. Absolute shit. I mean, this has already been debunked on this channel. The observer is bullshit. There's no such thing as the observer. It's just whether you interfere with it or not interfere with it. You can't view photons or electrons without interfering with them. There's nothing smaller than them that isn't going to be affected by something that isn't smaller than them. Duh. In the sense that you can't affect an electron because photons affect electrons, quite obviously. This animation isn't meant to be supremely accurate. Then what's the fucking point? I mean, you're just such a douchebag. I mean, Jesus. My security software is blocking the link, by the way. I would reiterate that I'm looking for animations accurately illustrating the mechanics of the so-called packet. At the very least, a comprehensive picture. Right. Well, the picture is some sort of Huygens bullshit, and the Huygens bullshit has to travel in front of the thing that eventually lands somewhere. Unless you are saying that photons can do math, and they know what the math is going to say, so they just go there. Alright, so this was a really dumb comment. Put some balloons in a room, heat the room where there are lots of particle movements in the air, watch the balloons form a solar system. I could make the same argument. Why doesn't bend space work? This pen is bending space, right? So if I put a piece of popcorn next to the pen, how come the popcorn isn't jumping right into the pen? This is bending space. How come the popcorn doesn't jump right to the pen? Oh, I guess it's the equation's a little more complicated than that. That you have to have a great deal of matter before you can just create a little bit of strong gravity. Yeah, and nobody's theory is arguing differently. So again, just a complete straw man piece of shit. I could say the same thing of his own bent space theory, and the same argument can be made, is that gravity is quite obviously something you build up. Like you have one proton, all right, 2 protons, 3 protons, 10 protons, 1,000,000 protons. You have to build it up. You gain a little bit with each proton. And so to have just enough gravity, it's all about just moving, again, a grain of sand takes just as much gravity to keep it in Earth's orbit as the Earth. It has nothing to do with the size of the objects you're trying to gravitationally affect. It has to do with how much gravity you can produce. And you can only produce gravity if you have a huge mass. The gravity needed to, say, move something, a grain of sand, is, in empty space, would probably require an asteroid of, pretty significant size just to keep a grain of sand in orbit around it. Idiot. How do balloons sufficiently shadow each other from kinetic straight line quanta force in a room full of relativistically static atmospheric pressure, equilibrium, whereby none of the particles are traveling in straight lines across the room, but rather bouncing off each other in random directions, retaining equal influence? Well, again, first off, these particles don't bounce off each other, and second, they are penetrating in the sense that most of them go through almost everything. You have to have like the thickness of the sun before you start slowing them down. I would argue that inside the center of the sun there's a lot of material pressure. That is, there's a lot of material bits pushing, but there's very little gravity there pushing. And that's why you're allowed to do all this nuclear fission and fusion and shit, is because everything that's keeping those protons, like I explained in the other video. See, there are elements of the other video that's good. Some elements are just going to be crap, but, that's the price you pay, draft and all. As pointed out, there's a minimum amount of, I guess I better try to keep the colors relevant. There's a minimum amount of, here's a proton. There's a minimum amount all the time of blue energy that's still going inside the proton and producing blue perpendicular, and that's happening all the way around. So there's a constant flow of blue out of protons. Not a tremendous amount, but it's always there. And so no electron can ever get too close to the proton, because there's always a little bit of energy coming out that's going to stop it. But once you lose gravity, then you lose the in blues. So then there's no out blues. And so then the electron can go into the nucleus. And all kinds of things can happen then. Same with the protons. Protons can actually crash into each other once you remove the external pressure. So I would argue that once you get a certain distance, an amount, density, density, a density of material, a thickness, it will block or shadow almost to a perfect black. And once you get to perfect black, then all kinds of funky stuff starts happening to the matter, because it doesn't feel any nuclear pressure anymore. It loses the strong and the weak forces break down, to put it simply. Alright, so he's basically desired mechanism. Either way, push-pull, you are left with the same converging vector force. I could also mention other flaws in your comparison: survival by momentum vectors, size, different requirements, etc., time. Well, I mean, the very idea that there's something about these mundane particles that would be at all interested in something, like a balloon, like somehow that would mean something, like that means it's easier to move, which it doesn't have anything to do with its gravitational relevance. A feather or a lead weight, gravity affects them the same. It's affecting the nuclear bits, not affecting the size. Size is irrelevant because each single atom is being gravitationally pulled. And you need a certain amount of mass to have enough gravity to produce enough shadow to even move a single proton or electron or atom, you could say. So it's moving a single atom that is the task, and moving atoms requires a lot of density. And so it's just a bullshit, silly, typical Puro troll comment, for which I'm really getting sick of. So do I want to make, I guess I'll throw it in here just because I just don't think I'm going to get to the gravity argument. I mean, he made these, these really stupid, ignorant comments in his stupid, ignorant video, because he doesn't really understand the sage gravity at all, Mach gravity, and how it functions, and how it just replicates the inverse square. And if you go to the page on Mach gravity, it's a Lesage gravity. Then now they just, well, they should give the original guy the credit for it, which is, I don't know why they, well, it's just the way history works, I guess. Unfortunately, the guy who invents it, has a tormented and lousy life, does all the hard work, and then some guy later takes his stuff and resells it and repackages it, and then he gets to name it. And that's just kind of unfair. I'm not saying he didn't fix it a little. I mean, I'm not saying he didn't have better illustrations, maybe, or something. But anyway, all you're trying to do is replicate the inverse square thing. And it is kind of funny that they make arguments like, well, the particle gravity, and they'll bring up things like the speed of light. The fact that the force would lag behind. So that is like, if your shadow was creating your gravity, then you would be moved to a new spot while your gravity, like say you're creating a shadow, the shadow is creating movement in the sun. All of that takes time. By the time the sun shoots back the response, you've moved over here, and therefore you're missing the gravity. But that's the whole point of the inverse square. That's exactly why the gravity gets weaker, is because of that fact. Because the gravity comes out in the entire forward dimension. So anything this way will be the response. So the gravity you're making is going to be there because it's going to be everywhere on that plane. So you can't miss it, so to speak. And the reason why it gets 4 times weaker as you move half the distance is because of these diverging lines. That's exactly the reason. Okay, it's weaker. Because it's not ping pong balls, literally. It's ping pong balls in a, well, I don't want to go into the ping pong ball example is just so good. But the ping pong balls are leaking out in all directions. So you will get your share of the 1 over r squared gravity. You just won't get the r gravity because the r gravity isn't how the mechanism works. Because there's force coming in all directions. That's the whole point of the thing. Is the pressure is all around, and all it needs to do is to compensate for a force this way, is to have any force that has a component in this direction. Alright, but I pointed that out before. But anyway, let's see if there's anything else stupid he said. Okay, so yeah, I'll just quote like Maxwell on Mach gravity. So it's on the website. So if you go to the Wikipedia page on Mach gravity or Lesage gravity, there's quotes by Maxwell where he basically just says, this will be the greatest thing in the history of mankind if this can be proven, blah, 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 blah. If this can survive, critical analysis and da-da-da-da-da. So clearly Maxwell recognized that this answers all the questions. And Feynman didn't bring it, he brought it, I mean, I play the clip of Feynman bringing it up, not because it doesn't work as a model of gravity, but because it has a symptom, it has a side effect that's unacceptable. Just like I could argue, well, Huygens might be a very nice idea, but the fact that it has to create an infinite amount of something inside of a small little space, well, that makes it fucktarded. So that's like a counter piece of evidence that it creates a paradox or something bad. And yes, so this mock gravity creates something bad if you don't really understand it in terms of the functions of electrons and protons, which are the things that's these are the elements that are being moved by the gravity, and these elements are affected, as I've tried to explain, through a force dynamic where if you polarize the force and make all the interactions purely kinetic, you get past any velocity problem. And I overtly explained the velocity problem. So he mocked that and said something like, I should be embarrassed, and that I'm somehow embarrassing myself because I have a theory of inertia that explains why things keep moving, and that theory of inertia completely fixes any kind of ether problem. But instead of acknowledging that truth, he just sits there and just, trivializes, because that's all he has is trivial arguments. And so, this is pitiful characters. Like I say, someday I will get around to playing his video just because it has so much crap in it. But, I have better things. I'm looking for better arguments and better human beings to converse with. So, I'll do that. Before I waste my time on a liar and a trivial thinker, which this demonstrates. Again, put some balloons in a room. Again, why doesn't bent space allow balloons to? Why don't balloons fall into proper orbits through bent space? I mean, space is being bent. Why isn't everything gravitating around everything here? Because everything's bending something. Why isn't everything falling into the gravity bended, hole? Oh, obviously because, yes, gravity is a little more complicated. Alright, anyway, so there was a few other images here that were just, they're all really very interesting. This guy says some ex-college professor type guy. But yeah, very interesting. So this is an old photo from the Michelson-Morley experiment, of their interferometer. But the interesting thing I found is that so they call these two different kinds of, it's like Fresnel and Fresnel or whatever kind of diffraction. But the diffraction that goes out, the lines get narrower and narrower and narrower, and the stuff that goes in seems like the pattern's always pretty even, which is interesting. I mean, I'm definitely going to have to do some pinhole experiments. This is a razor blade edge. Okay, so I mean, I've seen this a couple of times. I didn't know you could do that. So I mean, I know I could do this thing where you stick your fingers together and you can start to see little lines. But I mean, the interesting thing to do would be able to get a video camera and be able to get this kind of resolution of these lines, and then bring the other razor blade in and see if these lines start to thicken, and jump almost to the other razor blade. So this is a good image of the two kinds of diffraction. So this is just a ball bearing on a needle, and what's really interesting is you can see almost like this would almost look like, so here's the needle diffracting, and then you can almost see that the electrical potential of that needle is extending into the ball, and it's almost like a magnet with little flare lines that almost indicate almost a magnetic effect. And then you can see that the pattern on the inside is quite even, the lines. So that's the pattern going around the ball and creating the little whatever wazoo dot, the RE or whatever it is, anyway. So the ones going, so that's these nice even ones, and the ones going out this way are the ones going that way, deflecting, and they're all they get smaller and smaller and smaller. Now, what this, you know, it has a, like, it's almost like two patterns there. But anyway, very interesting photo. So this is just different gratings, you know, as you create more and more holes, what happens. And then there's some X-ray photos, and telescopes and diffractions, patterned, you know, how the patterns get fucked up in different ways when you put a different mask in the way. Very interesting stuff, X-rays. So this is ping pong balls, you know, just a strobe. But I just liked it was ping pong balls, right? Because I've been talking about ping pong balls. But this was the one that was, you know, sort of, yeah, very interesting also, is conical pendulum. So it's like a you know, a ball on a string, and you spin it around, you know, whatever you call that, Smurf ball or whatever. You hit the ball and it goes around, and you hit it and it goes around. Well, anyway, so this is like that kind of pendulum. So instead of swinging back and forth, you swing the pendulum in a circle. And it's just kind of funny how much it looks like a little galaxy or something. So I have to think on that one a bit too. Some rainbows and X-ray pictures, and but anyways, just some interesting photos here. Alright, so I'll leave a link to this below. And you know, just you know, for your own. I mean, they're just some pretty good photos. I mean, it'd be nice if, I guess, if there was some enlargements. You know, they don't enlarge. But anyway, can't have everything. Can't have much of anything most of the time. So let's see if there's anything else. So here's again different apertures creating different pattern. So you know, they have this single slit here. You know, and you get this, there's this single slit pattern with a medium aperture, and then you get this, the square does this pretty even thing. See, they don't have a triangle here, too bad. You know, and so the hexagon goes a little bit loopy. And it's the one next to that, the whatever the 7-sided one or 8-sided one goes a little nutty too. So, but I mean, look at all these bars here. So this is really the game. I mean, there's no point in saying this. You know, all these people keep saying, every time you see these bars, that means it's interference. Well, it's not interference. These are not interference patterns. You know, they're supposed to not be. And yeah, but you know, MIT professors say there is no diffraction of light. It's all interference. Puros say, no, it's diffraction, and then it's interference on top of the diffraction, whatever that means. That's not anything they draw. So, I mean, that doesn't exist anywhere. There's diffraction that creates dark spots. That's what they have to explain. Explain how diffraction creates these dark spots. Spreading, yeah, I don't need an explanation of spreading. What you need an explanation for is the dark spots. With round waves. And they don't have that. So anyway, but lots of images. And such. Here's some more mixtures of, well, two colors just gets too complicated. I don't think it really helps any. What do you want, cat? Alright, so that's probably enough. So, yeah, so it's a little bit of a distraction because I got to get up to speed on some of this stuff. But there does appear to be a subtle difference in the proportions between a single aperture, round hole, and the single slit in terms of the intensity issue. And I suppose that would make some sense because the center is a circle instead of now kind of a square, you could argue. You know, but again, that's more dynamics that have to do with what's happening inside the opening and less about what's happening after the light goes through the opening. I mean, it's, in my opinion, getting clearer and clearer, you know, that the story is what atomically happens inside the space occupied inside the slit. You matter affects matter. And so anyway, so yeah, one thing I did learn is, you know, all these apertures, you know, what causes all the flaring on images, and this doesn't entirely explain why telescopes create so much of that, but I mean, they shouldn't have apertures, right? They just have an opening and lenses. But I guess the camera that takes the picture is still a camera. What do you want? Did you mean you bothered me for nothing? No, I don't know if that's a good idea. It's really doing much better. You can get up there yourself. He doesn't know what video in is, so he's basically saying I should pick him up and put him on the chair and pet him and such. And maybe that'll happen, but it just I have to wait till I hit the button. So anyway, I don't think there's anything else I have to get to. I don't think there's any other brilliant comments. Sorry. Check. Whatever. You know, this crazy kook guy. Oh, that was it. Yeah, some guy made a video, basically, you know, pointing out what an idiot this guy is. So I should find that. I don't know. I mean, I don't have it on this. I don't think I have it on this computer. So I just switch. See if I have it open. Comments. It's not there. Well, it should be here. I guess if I jump ahead a little bit over here, I should be able to find it. In the search of DraftScience. There's a search on Emendum. Yeah, nobody likes me anymore. Anyway, yeah, this guy. Okay, Alexander the Genius. So I'll leave a link below to this video. Let's laugh at DraftScience comments. Yeah, the commenters on my videos really are idiots. Anyway, you know, it's just everybody's stupid, and so what do I expect? I mean, you know, yeah, it's just so bad everywhere. All right. So, not my best video, but I'll have to do for now until I get my brain to focus a little better and such and so forth and whatnot. I know there was some other issue I wanted to bring up, but I don't know what this is. I'm now wondering if something like Verlet integration could be applied to modeling to find the pressure changes for delta T between the electrons and the lattice with a spawned force. Okay. He says he's superior mind, so I guess so. I don't know what any of that is. But, good. Yeah, maybe. Yeah, that's what I'll say. Yeah, maybe. Alright, anyway. But yeah, most of the commenters are just idiots. What the fuck is this thing? Why do you bother? Well, Ken has just proven his theory with his supercell. Start thinking out of the box. Ken's in the box of like 400 BC. He thinks they were doing really good science back then, and that somehow we all fucked it up by doing this microscope telescope stuff. No, newsflash. Ken doesn't have a single clue. All he has is a lot of big words, but he hasn't still explained a single thing about how anything ever moves towards anything else. Which he doesn't think they do, actually. I think he thinks the space disappears, and so they don't actually move into each other. The space between them just goes away. I don't know what he thinks, but sorry. There's no explanation of how, you know, he even brings up Maxwell, because Maxwell was a bit of an ether nut, And so, I mean, if he has any respect at all for Maxwell, he's got to understand that they're straight line vectors is Maxwell's math. So how do you make these straight lines with a hyperboloid? But anyway, and whatever the opposite is, Punkenherloid or something. I don't remember what the hell. But anyway, it's just so goddamn stupid. So anyway, till next time, and probably the such. Oh, here we go, another one. I don't understand why people just can't let other people be. Ken constantly just grotesquely insults other people, and he has no balls. So you say, why you don't understand why people can't let people be, and Ken is gratuitously insulting, and yet he doesn't have the balls to defend any of it. I mean, he picks on dead people, for fuck's sake. What a cunt. Ken is brilliant. You know, Ken's interesting, funny, and he knows some stuff, but again, brilliant, you know. I mean, it's knowing the right thing that's important in life, and Ken knows a lot of stuff that ain't worth knowing. Can't he do his thing and you do yours, question mark? Well, that's really not the point. The point is, if you're going to claim you won every debate and you've defeated field theory and and you've done all these things and then you don't have the balls, you know, to face a challenge, that's disgusting. So what, people should just be able to lie and everybody should just sit back and say, okay, just go ahead and lie? You are a bully or just intimidated by him. Well, I guess you'd have to say it's the other way around, douchebag. If I was intimidated by him, I guess I wouldn't be sitting there saying, man up, pussy. You know, come on, bring it on, asswipe. He's the one who's afraid. So, I guess he's the one intimidated, quite obviously. Stupid asshole. Anyway. Why do you give relativity any credit? I don't even know what that means. I don't like relativity much. Why would you give light a constant? Well, because the implications of it not having a maximum speed, if that's what you were complaining about, would be devastating to the function of the universe. The whole thing would break. Isn't that diverging from the scientific method in itself? No, it isn't. You know, you're a silly person. And you should, you know, read a book on how not to be a silly person. Perhaps how you can get that out of light is a point you can pin, but that is not light itself. It's a place in the field. Jesus. But sometimes I get the feeling he doesn't understand it enough to explain it simply. He repeats words. Oh, okay, so you're the one who understands Ken's bullshit better than Ken, huh? This shit. Numerology, I don't even know why that comes up. Models that are disproven by what? So, I guess it's just such a complete waste of time. I guess I should look up this guy, Theodore de Correz. Sure, it's just absolute crap. You know, I couldn't post a link to anything, of course. The Torton Noble experiment, something I've never heard of. Oh, I'm sure it's just absolutely brilliant. I mean, experiments you've never heard of are always absolutely brilliant, right? Oh, no results. Guess he didn't spell his name right. Anyway, fuck it. Till the next time, such. And, yeah, I'll try to get myself wound up better. It's just, you know. Yeah, you know, I got the Lyme disease, and so that makes you feel kind of cruddy. But I also have, like, sciatica. It's just, you know. And you know, the Lyme can do that, but it usually goes away. Yeah, once you start taking the penicillin, it's just kind of lingering. Yeah, but I feel very lingering still. Anyway, but no fever, so it's, you know, I guess the penicillin's working. It just hasn't undone everything yet. Anyway, till next time.